So we've looked at a regular integral tells you the area under the curve, right? So if I said the integral from a to b of f of x dx, that is really just telling you if this is your function f of x, that should be a lowercase, and this is a, and that is b. That's what the integral tells you, right? Tells you that area. This is telling you that. Correct? All right. What if I give you something like this? We have f of x, do it in green. Oh, let me erase that. And that is g of x. So you have two curves, and I want to know this area right here. And we'll call that A, and we'll call that B. How would I do that? Just intuitively, what would you think you would do? That's it. That's exactly what you do. All right, you find the area of the top under the top curve, which would give you like all of this, right? And then you subtract the area under the bottom curve. Okay, so integral from a to b of f of x minus from a to b, and I should have put the dx in there. It's essentially the top curve minus the bottom. That's all you're doing. And because we can combine integrals when you're adding or subtracting, we can turn this into one integral instead of writing it as separate and just go, it's the integral from a to b of f of x minus g of x dx. That's it. That's all you have to do. So let's start with one of these. Fine. And this is how the questions will be worded if they're not given to you in pictures. Find the area bounded by y is equal to x squared plus 2, y is equal to negative x equals 0, and x is equal to 1. All right. I will either give you the curve or like give you a picture of the curves and label everything, and you just got to figure out what top and bottom is. But let's just, so we have a visual here. I'll let you copy that. I'm just going to pull up Desmos and enter this. So what are we going to get? X squared plus 2. Negative x equals 0. All right, so here this is on Desmos. All right. This is x squared plus 2 Negative x is this line right here. X equals 0 is that purple line right there at the origin. And x equals 1 is there. So this is the area that we want to find. All that matters is what is the top, what is the bottom. And we're going, between 0 and, what is it, 1? 0 and 1. Okay? I'll write this on the page, but just so, because we have it here. That's going to be the integral from 0 to 1. What's the top curve? X squared plus 2 is this one, right? Minus, what's the bottom curve? This line right here, which is negative x. That is your integral. Okay? So I'll just flip back and then we'll write it out. And Desmos, when you're doing these questions at home, Desmos is your friend. Because you can punch in the graphs on Desmos. So let's just get this set up, solve this, and then we'll go for a break. So our integral is 0 to 1 x squared plus 2 minus negative x dx. Simplify the integral before you do anything. So this one doesn't really simplify too much, but we can at least write plus 2 plus x. We'll need a double negative there. Now this is a polynomial. So it's just the most simple integral you can do. You just add 1 to the exponent, divide by your new exponent. So x cubed over 3, 2x, x squared over 2, evaluated from 0 to 1. Which makes our life even easier. As you plug in 1, and you get third plus 2 plus a half minus, you put in 0, everything turns to 0. If you want, you can make a common denominator. We'll even do this. So it's going to be 2 over 6 plus 12 over 6 plus 3 over 6. And if you add those all together, you get 17 over 6. Or, I don't know what that is. What's 17 over 6? What is it? What'd you say? What was your guess? Ooh. 2.83 repeating. I don't care if you give me the decimal or the fraction. I would prefer the fraction, but I don't really care. Okay? Does that make sense? All right. What if, we got one more example here. Actually, let's go for break. We'll do this on the other side of break. All right. What area are we talking about? So it's where the graphs intersect. And we have, this is one region here. And then we have, I'll do it in blue, this region here. Okay. So there's two separate regions. Why is this a trickier question than the one we just did? Other than there's two separate regions. What else happens? Yes, they flip in terms of which one is the top and the bottom. Okay? You can see on this part of the graph, it's the red, it's the f of x, 3x cubed, the trinomial, or the degree 3, sorry. And then in this section, it's the parabola, it's the top. So we're going to have to write two integrals. Okay? So the first bit, oh, and we should know where they intersect, but I will make that clear on the test. So they intersect at -2, 0, and +2. Okay, do that in black. So this would be -2, that's 2. Okay. So our first integral for the green section, I'll do it in green, is going to be from -2 to 0. And we're just going to write the general g of x, f of x for now, and then we'll actually do it. What's the top function here? It's f of x, right? The cubic. So it's going to be f of x minus g of x. That'll give you the green area. To get the blue, so then we're going to add the area of the blue. What's the integral going to be for the area of the blue? So 0 to 2 of the top, which is g of x, minus f of x. Obviously, you could do this an infinite amount of times if you really wanted to, right? If I wanted to be mean, but obviously I'm not going to. Okay, now we just have to fill in what we have. F of x is 3x squared, or 3x cubed minus x squared minus 10x minus g of x. You're subtracting the whole function, so put it in brackets. G of x is -x squared plus 2x. Plus the integral from 0 to 2 of, and then you flip them, -x squared plus 2x minus 3x squared, 3x cubed minus x squared, let me fix that, minus 10x. That's cubed, and this one over here should be cubed. There we go. Bracket, and these should all have dx's beside them. It's bad that I don't. I always forget to do that. There we go. Okay. Now it's a matter of doing it. But let's simplify it first, okay? Because I don't want to deal with that. So if you can make it simpler, that is going to save us a bunch of time. So the green part, combine your like terms. There's no other x cubed, so -x squared plus x squared. What happens to the x squareds? They go away, so they're bye-bye. -10x minus 2x is -12x. So that is simplified nicely. Plus do the same thing. There's going to be a -3x cubed because that's not going to go away. -x squared minus -x squared, so plus x squared, those go away, the x squareds go away again. 2x minus -10x, so 2x plus 10x is 12x. And that is all dx. All right, you now know how to do that. So go, please. And I'll freeze it, and I'll do mine. These things, it's all about the setup. Because I'm only going to give you polynomials. Yeah, I'm probably only going to give you polynomials or simple functions. And it's all about just setting it up correctly. But it's good practice to actually do the integrals. We get an answer? We're ready for the answer? Okay, just give me 1 sec here. Okay. Answer should be 24? Okay. Is that what people got? We all good? Why did you have a question mark?
It seemed like that was too easy. It's just like doing the same question twice and then adding that.
That's all you're doing. Oh, see, this is where these things get tricky. Is this because you're putting the 0 in first? All of that wipes out, and you get 0 minus, and you have to remember to bracket everything. Okay, and then do all this. 12 minus 24 is negative 12. With the negative there becomes 12. This side, same thing. And you get a positive answer. And the graph you're actually integrating, like that's obviously the area you're finding. But remember, we're doing these graphs, right? We're doing the integral of these. 3x cubed minus 12x from negative 2 to 0. So that's this purple one here. From negative 2 to 0. That's positive. Okay. And then this one, negative 3x cubed plus 12x, the black one, that one is going from 0 to 2. And there's symmetry there. Okay. So here, the point is, though, just, it's all about the setup. Okay? Look at the graph. They're going to flip. I'm going to give you a question like this, where the top function flips halfway through. Set them up properly. Simplify first, and then integrate. Okay? And then when you're integrating, just be careful with your signs when you're plugging stuff in. Well, when you're doing these, larger number always goes top. It's always read left to right. Okay, so from your A value, negative 2, your B value, 0. That's how you read it. Okay? Does that make sense? If you did it the other way around, you'd get a negative number. Good? All right. Questions I would like you to do are on page 442. I'm not going to give you a lot because there's a couple other things I want to do today. We don't have a lot of time left. So let's just do 442 number 3, please.